The second one here, I would like you to try it out on your own. And now let's look at this one. And let's see how the ratio test applies to this. So again, we are taking the limit of the n, as n approaches infinity, of the n plus 1 term divided by the nth term. Okay? And we are going to apply all of that, apply this definition to this particular series. So the nth plus 1 term is simply just replacing all the n's with n plus 1. So this is negative 1 to the nth plus 1, to the n plus 1, times n plus 1 factorial, divided by 1,000 to the nth. Okay? And so that's the n plus 1 term. Then we have to take that and divide it by the nth term. So the nth term is just exactly what we have written here, but now we are dividing by it, so we multiply by the reciprocal. Oops, made a minor mistake here. This should be n plus 1 right there. So multiply by the reciprocal. We're dividing by this term, which is the same thing as multiplying by its reciprocal. 1,000 to the nth, negative 1 to the nth, n factorial. Okay. So, and we want to see what happens to this limit, whether it approaches some number greater than 1 or some number less than 1 or maybe exactly 1. Okay. Now, because we have the absolute value here, the negative 1 to the nth doesn't really matter at all. We don't care. There's some cancellation there, but the point is it doesn't really matter because we're taking the absolute value. Okay. If we look at now these terms right here, n plus 1 and then 1,000 to the n plus 1 and 1,000 to the nth, well, that cancels out, and all you have left here is just 1,000, or 1,000 to the first power, or just 1,000. N plus 1 factorial and n, those do cancel each other out. Remember that n plus 1 factorial is nothing more than n plus 1 times n factorial. Okay, so this cancels out with that. On the numerator, we actually have a term remaining, n plus 1. Okay, so simplifying all of this, we get the limit as n approaches infinity, n plus 1 in the numerator, and in the denominator, we get 1,000. So as n gets larger and larger, this term right here will approach infinity. Even if it doesn't approach infinity, even if it approaches a number bigger than 1, we know that the series will diverge. So the series will diverge, and we know that by the ratio test. Okay. So there you have it. This completes this video. I will leave it to you again to work on the second example on your own. So we want to know really what's bigger, the exponential function or the factorial function. And you can kind of see in all three of these examples we have factorials. And the ratio test is useful for other things as well, but it's especially useful when we have factorials because we get this nifty idea here of the n plus 1 term canceling out almost everything from the n factorial, and that allows us to have a better grip on what the series is going to do, because it's really hard to take the derivative of the n factorial function since we don't really know what n is equal to, and in fact n could approach infinity. So this is again not the only reason we use ratio tests, but it does come in handy very, very often for these examples. Thank you for watching. As always, ask for help if you need it. Have a wonderful day.